Well, here we're gonna go for some DSA in C++, and in last I told you how to use ChatGPT for your DSA stuff. So use it and learn. So here I have a ChatGPT have, yeah, the ChatGPT have created a code, but I did created it, but there were some issues and errors, so I even used ChatGPT to rectify it. So here I will tell you how to do that. So first of all, this code is about creating a node at the beginning, inserting a node at the beginning, traversing, and making it in the reverse form. Like if it's 1, 2, 3, 4, 5, make it 5 to 5, 4, 3, 2, 1. That's what is ref function for. That's completed reverse. And here we also have to change reverse. All right. So the mistakes I made, I should make it again. The mistakes were I didn't declare this empty, I mean this linked list constructor. I didn't declare this, so this was a mistake. And the thing, I didn't put return here because I thought it's a void function, so maybe you don't have to return anything. So here, this is what it is. And here I wrote in the condition that if there's no head, that's what I wrote here. And yeah, everything all is fine. Yeah, I wrote very well in main function because it's just, creating a object and stuff. So now let's run it and see what happens. It will gonna be fun or not, or gonna show some gibberish address. We don't know. Let's wait. I don't know why it's taking so much of time. Okay, so let's just open ChatGPT in a new tab. Okay, it didn't put anything. I will tell you. Here, look at it. It didn't give any output. Let's run it again, and you will be knowing that it doesn't give any output because of those errors. So if I copy this whole code and put it in here, chatgpt.com, and here come here and paste your code, and it will rectify the whole goddamn code, and you can just know what's happening. Here, see, constructor for initialization. So I removed the constructor in front of you. So here's that constructor to initialize the head to null pointer. So it's a way to, create a constructor. Instead, you can do what I did was, okay, let's just check it out, whatever I removed. Okay, so the thing was the video got paused and I don't know where it got stopped, but let's just check out. Again, the thing was I was telling is that you can use ChatGPT to rectify your code, and here the ChatGPT told us to put the constructor, default constructor. This is default constructor. You can either write it this way, or you can just either write it this way. I don't know if I've told you that, but you can write it this way too, and this way also, however you want. After that, you just have to create this insert at beginning function. But here in if condition, if you don't put the return, which I'm gonna remove right now, and let's check what happens. Here the 5, and the 5 is coming from here insert at beginning 5. If I change it to something like 21 and stop this code, save it, and let's run it. And now 21, 21, 21 will be okay. Let's do it again. All right, here you can see 21 is getting printed again and again and again because we haven't put the return in if condition. We do have to put because we want the compiler to return back to its original, I mean to the back to the starting code, because we don't want to rerun it again and again. Without return function, it just continues and print it again and again and again. So that's we do not want to do. So that's how it happened, and I'll tell you what we did here in the linked list thingy. Here we have included a library IOStream, which is input output stream for C++ using namespace std. You know about all that. Here we created a structure whose name is node. Here you can see that, and it have two things, which is one is data, which is of integer type, and other is next pointer, which is pointing towards the node type. So it will be pointing towards a new node from the structure node only. So after that, we have created a class linked list in which we have public access modifier, and you have to put public because the default modifier is private. Even if you don't put the private access modifier, in the starting, it's all fine because the default is private. So you do have to put public because public should be put it because it should be, it's not default. The private is default. So if you want to change to protected or public, you have to put it. For private, it's not necessary. Then we have created two pointers pointing towards the node, which is a head and a prev. Prev means the previous. You can just put anything you like. Here, we have created a default constructor, which is of linked list, telling the head is equal to null PTR. We have to define it for the first time because we just do have to define it to make the head exist somewhere in the list. Even if it doesn't, we have to make it exist. Even if it doesn't means null PTR, null pointer. So you have to make it exist by this, initializing the constructor. Then we go for the function insert at beginning, which is in at back, and here we are passing in an argument which is integer of value, which helps in such as this kind of thing. When I wrote 21, the user or anyone will wrote 21 in the function insert at beginning, and this is the integer argument which I have created there here. So that's how it's gonna insert that number, that value at the beginning through this value integer. And here we have created a new node, I mean a pointer new node, which is pointing towards the node. And the new node is equals to creating a new node. And this new thing is creation of new. And this node means this node structured. You can see the node is same here. It's a creation of new node which consists of integer data. I mean, it have two things, data and the pointer to next node for the next. I mean, list, it's a list. So it should be pointing towards the next one. So here we created a new node, which you can see here. And here, if the condition is this, that head is not there, that if the head is equal to null PTR, that means there's no head, then the head will equal to a new node. This new node will be equals to head. That's what I'm saying. Head will be equal to new node, and the new node data will equal to value, which is this value. We have passed in the argument. And the new node next, as this is the first node, there won't be any next node. So it will be equal to null PTR, and head will be equal to new node, which is next is null ptr. So head is won't be equal to null ptr. Head will be equal to new null. So here we have to put return to end this to finish this if function here. We have to do that. If you don't do that, you know what happens. It's got continuously printed and printed and printed. So that's what happens. Here we will see this new node. If I mean I'm saying not this if this function, if the function of this if doesn't run, the compiler will come to here. And the new node data, here we have already created a new node from the new node. Okay, so the data will be equal to value. We have to write this again because this value is in this if condition, and this is out. So this is outside the if condition. So we have to write it, and then we don't have to write it before. We will write it later because we first have to define the new node data will equal to value, and the new node next will equal to head. Then after we can define that head equals new node because if there's head present in the list, so what we have to do, we have to create a new node through equals new node, and then new node next would be head. So the new node we have created will come before the head. You getting it? New node's next part is head. This means that the before head, this new node will come, and that's how we insert at beginning. And now the head will be the new node, which is the head will be getting to previous number or point, whatever. So that's why we define it later. Because we would have done this, wait, cool. If we would have done this, then what would have happened is that head will be equal to new node, which means the head is already a new node. So you can't be doing that. The head's new node next is equal to head. You can't do that because head is equal to new node already. So you can't do that. You have to keep that in mind. Every code is executed line by line by line in a sequential process, all right? So you can't just be like putting anything above anything else. And then we have created a traverse function, which means going through each element for once. This constant const is a function to avoid any errors, like if avoid any changes in the list. Like if I remove this const, I will show you what happens. Here it will run very fine. You can see. The list is 21, 15, 35, and 4C. Now if I remove this and now see what happens. It's showing no list. Why? Because I already defined the head is equal to null PTR. But if I just command it, it will run fine. So if I don't command it, you know what it shows? It shows no list. But if I put const here and now see what happens. It's saying error assignment of member linked list ahead in read-only object. You can't modify it. So to not to modify the thing, you have to write constant so it const. So it will give you error and will let you know that there is an error. So you will just remove it or just comment it, and now it won't give any error. It will tell you that it's all fine now. 21, 15, 35, 45. But if you don't put it, you know what you saw. You saw this no list thing, which shouldn't be happening. That's why you put const to not to modify it. And here we created a node temporary pointer, temp pointer, which is pointing towards a node type and which is equals to head. All right, we are traversing it. We are going through each element for once. So of course we're going to start from the head. So if there's a if condition, so if head is equal to null PTR, which means the list doesn't have anything because head is already equal to null PTR, which means there's no list. Okay, and here either the if condition will gonna get compiled or this while condition. So here we have to put return because if we don't, you know what happens. Let's just remove it and see. Actually, there is head. The head is not equal to null PDR, but if we just do this and remove the constant, see here. It's okay. You have to return with because if you don't, it's getting printed again and again and again. That's why you have to put return. So now it won't show no list and it will be showing 21, 15, 35, 45. Okay. So here this traversing is done for the head if head is equal to null. Then we go to val if the temporary which we just have created this temp pointer is equal to head. If temp is not equal to null ptr until while means until the temp is not equal to null ptr, it will be running again and again and again until the temp is not uh, I mean till the temp is not equal to null ptr. It's not until, it's till. While means till the temp is not equal to null ptr, this will be running again and again. And when the temp will be equal to null ptr, it won't run anymore. So here, when the temp is not equal to null ptr, it will be running cout temp equal to data. So temp is starting from the head. So it will be first printing the data of the head and then the space. It's not necessary, but if you put it, it looks good. Here you can see in the between 21 and 15. That's the space. And after that, we are doing temp is equal to temp of next, which means the temp, first the temp we declared is head. The temp is equals to head, but then we have to traverse, we have to go through each element. So for that, we have to put the temp first the head, then after the head, then after the head, we have to do that. So temp will be equal to temp of the next. So the temp of the next will be the node after the head. So the temp will be equal to that. And after that, it will again run because the temp is not equal to null PTR. And the moment the temp will be equal to null PTR, it will be, getting ended. So here is the reverse function, which we have done using three variables, which is temp, prefs, and next. So the temp is already equal to head. I mean, we have defined it. And the pref is equal to null PTR, and the next is equal to null PTR. All right. So this is also a very small function to reverse the linked list. Here the while, this means the temp will, this loop will run till the temp is not equal to null PTR. When the temp is equal to null PTR, this won't run anymore. So here what we did is that let's start from starting. I will tell you. So here the temp is equal to head. So just consider this 21 as head. So this is the temp now. And after that what we did was that next is equals to temp of next. So this next null PTR is equals to temp of next of the temp. So temp is this. The next of temp is 15. So the next will equal to be 15. Okay. Now you know that the next is equal to 15 here. Now, the temp of next is equals to prev. The temp of next is equals to prev. The temp of next is what? The temp is currently the temp is 21 only. So the next of 21 will equal to be prev. Prev means null pointer. So the next of 21 will equal to be null pointer. Right now, the next of 21 is 15. Right now. And after writing this second line, this means that next of 21 will be null PTR. That means there will be no nothing in the list after 21. Okay, now we will write the code prev equal to temp. The prev is null PTR right now, and temp is equals to 21 only. So prev is equals to temp. This means that prev is equals to 21 now. Okay, now the temp is equals to next. So next was 15. We have defined it in the first line of the code. So the next is equal to 15. Now the temp is equals to next. So now the temp is not 21, the previous is 21, and the temp is 15 now. So this loop will run again until the temp is equal to null PTR, and null PTR will be after 45. So temp will run until it's 45. All right. I mean, this loop will be running till then. So just consider it like that only. Now the temp is 15, okay? So the next of the temp will be temp's next. So temp is 15. The next of the 15 is 35. So next will be equal to now 35. Now the temp next equals to previous prep. So the next of the temp is 15. The next of 15 will be previous, which is 21 now. We have defined, I have told you in before only. The previous is 21 now. The next of the 15 will be now 21. Okay, now the previous will equal to be temp. Now temp is a 50. Oh my god. The temp is 15, and now the previous will equal to be 15. And the temp is equal to next, and next is already we have done in this one. Next is 35, so the temp will also be equal to 35. That's how it will be running again and again. Now 15 will be pointing towards 21, 35 towards 15, 45 towards 35. Okay, so and now at the end we have to start from when we traverse the list. We have to start from the head. So we have to make this 45 the head. So the prep will be 45 and the next will be null PTR here. When the loop will be completed, the next will be null PTR and the prep will be equal to 45. So we have to put head is equal to prep because we have to start from the 45 as the head. So here I have already reversed it. Let's reverse it again and see what happens. All right, here you can see. Now the 45 is the head, 45 is pointing to the 35, then 15, then 21. That's how you can reverse a list. All right, that's what a reverse function is, that's what a traverse function is, and that's how you can do things. Like if I add some more here, and let's make it 22. Okay, it's too cool. I mean, 2 is cool. And now 67, and 45 is already done, 95 or 92. All right, now see the list. I will just remove this reverse function for now, and now see the list, what happens. First, the 21 came and it's insert at beginning. So it's not like 21 and then will be 15, then 35. No, it's insert at beginning. So 21 got inserted for the first time, then at the beginning. So 15 will be inserted before 21. Same way, 35 will be inserted before 15. And the same way, 92 will be inserted at the beginning. So 92 will be starting from then 67, then 2, 45, 35, 15, and 21. Now if we put this, okay, let's do it twice here first without reversing it, and then L1 dot reverse, and this function starts, and here we will traverse it one again, L1 dot traverse. All right, so you will see two lists now in forward and backward form. Here you can see first is getting printed in the all right form. I mean, it's the list we have created, and now after reversing it, it looks like this. You can see the 21 is now head, and now it's pointing towards the 15, 35, 45 to 67, 92. That's how you can use the reverse, create a reverse function in DSA. Now we are going to do, what we are going to do is create a deletion function. So for that, you just have to create a new function here. Let's close the terminal, and here just create a new function, which will be void, not void del at beginning. Yeah, let's create the deletion at beginning first. And beginning means beginning. You don't have to put any integer value in that. So let's just repeat. Deletion at beginning means the very first node. The very first node. We have to delete very first node. So we will write again the temporary thingy node. We will create a pointer of temp. Yeah, the ttemp. All right. Okay, ttemp. Now the thing will be that if there's no head, then oh my god, okay, right. Um if what? If there is no head, cout no element program. Cool. And after that, we have to return. Just keep in mind, return. All right. Now we will write, we have created a temp which would be equal to Had. Cool. Oh my god, not had, had. Okay. So here it's equal to had. Now what we have to do, we have to um, do is that had will be equal to had will be equals to the next of the temp. You getting it? T T temps next. Had will be equal to this because we are deleting the first at the beginning, and now we will delete T because we have to remove it. We don't need it. That's why. So I hope it's all right. So now let's just create this here after here. Okay, let's reverse it. After reversing it, we are gonna delete using the delete function. So L1 dot back, and what will be happening is that let's just go to the terminal. Okay, let's just run it. Okay, yeah, it's fine. It's very well written. So here, what happened is that first we traverse the code as it is, like the list completely from 92, 67 to until 21, and then we reverse it first. We first reverse it. We didn't delete the first. We reversed it first. So we reverse it, and then the reversing will be happening like 21, 15, 35, 45 to 67, 92. So the 21 will be the head now. The 21 is the first element. So we are first reversing in and that then deleting at the beginning. So the beginning element after reversing is 21 and 21 is deleted. So we will be starting from 15, 35, 45 to 67 and 92. But if we did that before, let's put it above and now see what's happened. The 92 will be deleted as you can see because we deleted before. So the 92 will be deleted here. The 92 is deleted and then it got reversed. So 21 till 67. That's how it works. So that's how you can create the delete at beginning function. And if we just put here, let's put that had um, actually had is equal to no pointer. All right, now let's see if it, okay, here you can see um okay, no element present. We have to put space here. What this no list is coming from? The no list is coming from traversing. That no list came from traversing, not from that, delete at beginning thingy. All right. So here you can see. Let's put space and end of the line too. End of line. All right. Now let's print it, and you can see no element present, and so therefore no list because the head is equal to null PTR now. That's why you have to write this if condition. If you don't write this, let's just comment it. Now see what happens. Now I don't know what will happen, but let's just check it out here. So if we don't write the if condition, that head is don't got it. So it does its thing. Even if the head is null PTR, it still does its thing. That's why you have to write the if condition. All right. So if condition is necessary, and when you write if condition, you have to return to end that code, that compilation of that particular code. That's how you can write delete at beginning. And the same way you can, not the very same way, you have to first traverse if you want to delete at end. So if I want to delete at end, you have to traverse the temp, you have to traverse the temp first to the last node until the temp is equal to null PTR. That's what you have to do. Okay, so keep coding and use ChatGPT for your help. If I write, okay, write a function for delete at beginning. So here, go to the code already. Here, void delete at beginning. So here, this means the same. What we did is that if there is no end, okay, let's do this. Delete at